So today we'll be solving a physics buoyancy question, and the question reads, a cubical block of iron 10 centimeters on each side is floating on mercury in a vessel. 1. What is the height of the block over the mercury level? And 2. Water is now poured into the vessel so that it is just above the iron block. What is the height of water column? If density of mercury is 13.6 grams per centimeters cubed and density of iron is 7.2 grams per centimeters cubed. This question is definitely a little tricky, and whenever you come across a question that you find you're stumped on or you're just stuck and you can't really understand the concept, I always find that the easiest thing to do is to draw out the scenario. And that way you have a clear understanding of what the question is asking. So let's start by breaking down the question into parts. We've got a cubical block of iron that is 10 centimeters on each side floating on mercury in a vessel. So let's start by drawing out the vessel. Next, I'll draw the cubical block of iron that is floating on mercury in the vessel. So let's assume that this is a perfect cube and it is floating in mercury. Now we're interested in the height of the iron cube above the mercury level, so let's call that height HA. The next step is to look for the clues that the question has given you. For example, you've been given the density of both mercury and iron, but you're interested in finding the height of the iron block above mercury. So what you have to do is to think about the relationship between the density and the height. So let's start by defining density. Density is simply weight, in this case, over volume. And this can be rewritten as divided by width times length times height. Oh, and look at that, there's the height that we were looking for. So now we're on to something. The next clue points to the fact that the iron cube is floating on mercury. The term floating should remind you that this is a buoyancy question. Therefore, in this case, the weight of the block should equal the weight of mercury dispersed. So let's start by defining the weight of the block. We know from the question above that the density is equal to the weight divided by the volume. Therefore, if we just multiply both sides of the equation by volume, that would move volume to the left-hand side of the equation, multiplying density, and that leaves us with the equation that the weight of the block is equal to density times volume. Now let's define the weight of mercury dispersed. It is equal to, now if we plug in the numbers, we have 7.2 grams per centimeters cubed times the volume, which is 10 centimeters by 10 centimeters by 10 centimeters, which is simply 10 centimeters cubed, which simply translates to the weight of the block equals 7.2 grams. Now let's define the weight of mercury dispersed, bearing in mind that this weight is defined by the density of mercury multiplied by the volume of mercury dispersed. This is the tricky part, because volume of mercury dispersed is actually the volume of the cube immersed in the mercury. In other words, 10 centimeters by 10 centimeters multiplied by the height of the cube, which is 10 centimeters, minus the height of the cube that is above the mercury level. Tricky, right? So let's rewrite this. So the weight of mercury dispersed is equal to 13.6 grams per centimeters cubed times 10 centimeters squared, which is simply the 10 centimeters times the 10 centimeters we multiplied above, multiplied by the difference between 10 centimeters, the height of the cube, minus the height above mercury. So the weight of mercury dispersed is equal to 13.6 grams per centimeters cubed times 10 centimeters squared times 10 minus the height above mercury of the cube, centimeters. The centimeters simply cancel out, and this simply leaves us with 13.6 grams times 10 minus HA. Now that we know what the weight of the block is and the weight of mercury dispersed, we can equate the two equations to each other. So 7.2 times 10 cubed grams equals 13.6 grams times 10 squared times 10 minus HA. We can now simplify this question by dividing 7.2 times 10 cubed grams by 13.6 grams times 10 squared. And this can be further simplified to solve for HA. And now we can move on to the second part of the question. So the only difference between the first part of the question and the second part is that now water has been poured into the vessel. So here we have my vessel in which water is just covering the iron block. So I'm clearly no artist here, but hopefully you can still see the height of the water column, which is represented here by HW. So we're still maintaining the original equation that weight of block equals weight of mercury dispersed, except now we're adding the weight of water dispersed, which is simply the density of water dispersed times its volume dispersed. This translates to 1 gram per centimeters cubed for the density of water, which the question assumes you already know because it does not mention it, times the area of the cube, which is just 10 squared, times the height of the water column, which simply translates to 1 gram per centimeters cubed, the density of water, times 10 squared centimeters squared, the area of the cube, times the centimeter distance of the height of the water, HW, which is simply 10 squared times the height of water, grams, which is simply the area of the cube, 10 squared, times HW grams. The weight of mercury dispersed is still 13.6 times 10 squared times 10 minus the height of water this time, grams. So the only thing that has changed here is HW, which is there to reflect that we are looking for the height of the water column this time. The weight of the block remains the same. It is still 7.2 times 10 cubed grams. This translates to 7.2 times 10 cubed grams equals 13.6 times 10 squared times 10 minus HW grams plus 10 squared plus HW grams. This reduces to 7.2 times 10 grams, which equals HW plus 136 minus 13.6 times HW, which then finally reduces to HW equals 5.1. Therefore, by adding water to the vessel, the height of the cube above mercury increased to 5.1, so a difference of 0.4 centimeters. If you have a question that you would like to be submitted in next week's tutoring Thursday, please submit your question to questions@academicgurusinc.com. If you enjoyed this session, Please give us a thumbs up and subscribe or leave a comment just to let us know how we're doing. Until next Thursday, happy studying.